So now we're going to take a look at test drive number 4. So problem number 1, a person is buying a birthday cake for a particular cake. It is available in 12 different flavors, 8 different icings, 10 different fillings, and 4 different candle types. How many choices does a buyer have with the cake? And this is just a direct consequence of the counting principle. We're just going to multiply those numbers together. The 12 flavors times the 8 icings times the 10 different fillings times the 4 candle types. And we're just going to go ahead and do that multiplication on our calculator. And that gives us 3,840 choices. All right, let's try number 2. A school track team with 24 members is to choose 4 different members for a relay team. Leadership, or leadoff I should say, position number 2, position number 3, and anchor. How many ways can the relay team be selected? So in this problem, order is important. So this is going to be a permutation. We have 24 people and we're picking 4. So on our calculator, we're going to type 24, do our probability key, NPR, 4, enter. And that will give us 255,024 ways that team could be chosen. Let's try number 3. How many 6-character codes can be formed from the characters 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, A, and B if repetition is not allowed? So again, this is going to be a permutation. We got total 12 characters. There's the 10 digits plus A and B, and we're picking 6 of them. So we're going to evaluate 12p6 in our calculator. So that gives us 665,280 codes. Let's try number 4. How many different ways can the letters of the word inspirational be arranged? So you want to remember this is a duplicate items permutation. So it's going to be n factorial over basically how many times each of those letters repeat. So we're going to first count the number of letters in inspiration. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 letters. So that's going to be our numerator. 13 factorial. And now we have to look for the repetition. Well, we have 1, 2, 3 I's. 1, 2, 3 I's. So that's going to be a 3 factorial. Let's see what else repeats. We have an N here and an N here, so it looks like we have 2 N's. And let's see what else. Only 1 S. Only 1 P. Only 1 R. Looks like we have 2 A's. 1T, 1O, and 1L. Okay, so we'll have to put that as a fraction in our calculator. So we're going to hit our fraction key. And I'm going to do 13 PRB. And remember, option 3 is our factorial. And I'm going to put 3 PRB option 3, 2 PRB option 3, and another 2. So we still get a huge number. 259, put a comma there. 459, comma 200. So that's 259,459,200 ways that can be arranged. Let's take a look at number 5. An election ballot asks the voters to select 5 city council members out of a group of 20 people. How many ways can this be done? Now, it doesn't matter how those 5 council members are selected. So this would be a combination. We have 20 people and we're selecting 5. Of course, here order is not important. So that gives us 15,504 ways that can be done. All right, let's take a look at number 6. If 7 numbers in a lottery are drawn from 50 numbers in a state lottery, how many ways can the numbers be drawn if repetition is not allowed? So again, that's a combination. So in this lottery, we've got 50 numbers, and we're picking 7. So it looks like we get 99,884,400 ways that can happen. All right, let's look at number 8. If a fair six-sided die is rolled, find the probability of rolling a 4 or less. So I skipped over number 7. I'm sorry. So let's try again. How many ways can a committee of 5 students and 3 faculty be selected from 20 students and 6 faculty? So we're selecting 5 students from 20 students, or it doesn't matter. So 20, and we're picking 5. And we're selecting 3 faculty from 6 faculty. So both of these are combinations, and we're going to multiply them together. So I'm going to do 20 PRB to 5. It's 15,504. We actually did that earlier, but that's okay. And I'm going to do 6 NCR 3. That's 20. And now we're going to multiply those two numbers together. So 310,080. And so that's how many ways that committee can be selected. All right, so now we're ready to go to problem number 8. If a fair six-sided die is rolled, find the probability of rolling a 4 or less. So rolling a 4 or less would be a 1, 2, 3, and 4. So we have 4 ways that can be done. Out of a six-sided die, there's 6 ways you can roll the die. So our probability reduces to 2/3. Again, I'm just kind of going back to that formula. Number of outcomes in E. Well, 4 or less, there's 4 outcomes. Total possible outcomes would be 6. So 4 over 6 reduces to 2/3. Let's try number 9. If 2 cards are selected from a deck of 50 cards with replacement, find the probability of selecting 2 kings, a king and a queen, or it does not matter, or 2 queens. Alright, so we have to think about this. We are doing this with replacement. So there's 4 kings and 4 queens in a deck of cards. So we're talking about a total of 8 cards. And we know there's a 52. So the first time through, probability of selecting a king or a queen would be 8 out of 52. Now since this has replacement, we're going to put those cards back in. And so second time through would be 8 out of 52. If replacement was not allowed, then you would only have 7 choices out of 51 for that second fraction. But here they say with replacement, so we're putting it back in to the deck. So we'll just do this as a fraction. 8 over 52 times 8 over 52. So that'd be 4 over 169. Alright, so let's turn the page. Okay, a family has 4 children. Find the probability that 3 or more of the children are female. Alright, so let's get a clean sheet of paper. And I think it's easiest here to look at the sample space. So that's what I'm going to do here. So the first child can either be a boy or girl. Okay. Then the second child can be a boy or a girl. Third child can either be a boy or a girl. And then finally, the last child can either be a boy or a girl. So it gives us a total of 16 things in our sample space. So first one would be all girls. Second would be all girls and a boy. So the first 3 are girls, the last child's a boy. And then we can have girl, girl, boy, girl. Girl, girl, boy, boy. And then we have boy, girl, girl, boy, girl, girl. And then girl, boy, girl, boy. And then girl, boy, boy, girl. It should be a, got these backwards here. My dyslexia kicking in there. and then girl, boy, boy, boy. And I'm going to do the same thing down here. We have boy, girl, 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 boy, girl, girl, boy, boy, girl, boy, girl, boy, girl, boy, boy, and then boy, boy, girl, girl, boy, boy, girl, boy, and then finally boy, 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 girl, and boy, 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 and boy. Oh boy. So we should have 16 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's how many ways you can have 4 kids. And we want to know that 3 or more of the children are female. So 3 or 4. There's 4, there's 3, there's 3, there's 3, there's 3, and that's it. So we have 1, 2, 3, 4, 5 ways you can have 3 girls. There's a total of 16. So our probability would be 5 over 16.